Hi guys, today we're going to solve another infinity square root problem. I love infinity because it's you can visualize your imagination with specific numbers. So that's is pretty cool. So let's take a look at this one. This number equals, the first two here is 2 to the power of 1 over 2. And then the 4 here, because there are two square roots before 4, so it is 4 to the power of 1 over 2 and then 2 squares. So then times 8, 1 over 2, and then to the third power, times 16, 1 over 2, fourth power, and then keep going. So this actually equals 2 to the power of 1 over 2 times 2 square to the power of 1 over 2 square times 2 third to the power of 1 over 2 third power times 2 fourth 1 over 2 fourth, and then go to, let's say, 2 to the power of n, and 1 over 2 to the power of n. And this one actually is 2 to the power of 1 over 2 times 2 to the power of 2 times 1 over 2 second times 2 3 times 1 over 2 third times 2 4 1 over 2 4, and then go to 2 to the power of n times 1 over 2 to the power of n, and then keep going. So this actually equals 2 to the power of 1 over 2 plus 2 times 1 over 2 square, then times 3 1 over 2 third times 4 1 over 2 fourth, then plus n times 1 over 2 to the power n. Alright, so then go to the limit. Let's set the power of this part equals s. Then 2s is 1 plus 2 times 1 over 2 plus 3 times 1 over 2 second plus 4 times 1 over 2 third, and then n plus 1 over 2 to the power of n minus 1, and then keep going. So then 2s minus s equals, if we look at this way, use this one minus this one, this one minus this one, this one minus this one, and then keep going. So keep going like this. 1 plus 2 minus 1 times 1 over 2 plus 3 minus 2 over 1 over 2 second plus 4 minus 3 times 1 over 2 third, and then n minus 1 times 1 over 2 to the power of n minus 1, and then keep going. So this actually equals 1 plus 1 over 2 plus 1 over 2 second plus 1 over 2 third plus 1 over 2 fourth, and then go to 1 over 2 to the power of n minus 1, 1 plus 2 to the power of n, and then keep going. Now, this is actually a geometric sequence, which is gonna learn in high school. So it is an equals a1 times q to the power of n minus 1. For this case, it is 1 times 1 over 2 to the power of n minus 1. And the sum of this sequence is a1 times 1 minus q to the power of n over 1 minus q. So for this case, this equals 1 times 1 minus 1 over 2 to the power of n one minus 1 over 2. So it is actually equals 2 minus 2 times 1 over 2 to the power of n. When n is infinity, 1 over 2 to the power of n equals 0. So this sum is actually equals 2. The sum equals 2, which means this number is here, s equals 2. So 2 to the power of 2 is 4. So the value of this number is actually 4. And for this geometric sequence, if we want to prove that, we can let this number equal t, which is 1 plus 1 over 2 plus 1 over 2 second plus 1 over 2 cubed, and then go to 1 over 2 to the power of n, and then keep going. And then we can know that t over 2 equals 1 over 2 plus 1 over 2 second plus 1 over 2 cubed plus 1 over 2 to the fourth power, and then keep going, 1 over 2 to the power of n plus 1, and keep going. Then t minus t over 2 equals, so this one minus this one 0, this one minus this one 0, this one minus this one 0, and this one minus this one 0. So it is actually equals 1. Then t equals 2. All right.